Welcome to 6-4 Part 2. Now, in 6-4 Part 1, we talked about consistent and inconsistent systems. And inconsistent systems had no solution, and consistent systems had either one solution or many solutions. Now, with consistent systems, there's two more qualifications that we can have. A consistent system can also be independent. Now, independent means it has one solution. Now, the way that I remember that is if you're independent, you can kind of do things on your own. Like, you don't need a lot of people, so that's, one person doing things on their own. So an independent system has one solution. A dependent system is one that has many solutions. And if you think about the word dependent, if you're dependent, that means that you're counting on other people to help you out. So many solutions, lots of people working together. So independent has one solution, dependent has many solutions, and those are further classifications of a consistent system. Okay? So a system can be consistent and independent, or it can be consistent and dependent. But inconsistent systems are never independent or dependent. They're just inconsistent, period. Okay? So what we're going to be working on today is just classifying systems. So we won't actually be solving the system, we're just classifying it. And on page 407 in your book, you'll find this chart. And this chart's very helpful. I would put it in your notes if I were you, because you'll probably be looking back at it quite a bit. So what's going to happen here is this kind of just describes what each system looks like. So you can see here in the first column, if we have a consistent and independent system, it means it has one solution. And the equations will have different slopes, which we're going to use that part to really help us classify without solving. And if we were to graph it, we would have lines that intersected at one point. Then the second column there, we have consistent and dependent, and those are systems that have many solutions to them. And if we look at their equations, they're going to have the same slope and the same y-intercept. And when we would graph them, we would get the exact same line. And then the third column here, we have inconsistent systems. They're ones that have no solutions. And if we look at their equations, they have same slopes but different y-intercepts. And when we graph those, we would get parallel lines. So what we're going to do when we come across a system and it says classify the system, meaning not solve but classify, what we'll want to do is put each equation into slope-intercept form. So if I look at this top one here, I have to divide everything by 3. So I would have y equals 1/3 x plus 1. And on here I'd have to add the 1/3 x. So on that one I would have y equals 1/3 x plus 1. So now they're both in slope-intercept form. Now if I look back at my chart, okay, it says that I'll either have different slopes, I'll have same slope, same y-intercept, or same slope, different y-intercepts. Well, if I look here, I have same slope, they both have a slope of 1/3, and I have same y-intercepts, they both have a y-intercept of 1. So if they have the same slope and the same y-intercept, if we look at our chart, that tells us that this is a consistent and dependent system. And then also notice in the directions it says tell the number of solutions. So consistent and dependent, and those types of systems have many solutions. So that would be my classification of the system. And notice, like I said, I don't actually have to solve it. I don't have to graph it or do substitution or anything like that. I can just tell by looking at the equations. And we use that when it says classify. If it says solve, then we would actually solve it. Let's look at another one here. So once again, the first thing I want to do is put it in slope-intercept form. So maybe I should write a step here. First thing, slope-intercept form. So to get the first one here, I'm going to have to subtract the x. So I'd have y equals negative x plus 5. And on this one, I'm going to have to subtract the 4. So I'd have y equals negative x minus 4. So now that they're in slope-intercept form, I notice that these guys have same slope. They both have a slope of negative 1, but different y-intercepts. So if I look back at my chart, okay, same slope, different y-intercepts, that tells me it's an inconsistent system. Okay, meaning when I graph this, I would have two parallel lines that never intersected. Now, how many solutions does an inconsistent system have? None. Okay, so it would have no solutions. Alright. Let's look at just one more here so we can get an example of each type. So once again, the first thing I want to do is put it in slope-intercept form. So this first equation here, I just have to distribute. So I have y equals 4x plus 4. And on this second one, all I got to do is add 3 to both sides. And I'd have y equals x plus 3. And you can see here, I have different slopes. And if I look back at my handy-dandy chart here, if I have different slopes, that means it's consistent and independent, and it has one solution. These are long words. One solution. Okay, so that is how we classify systems. So that's 6-4. Let me know tomorrow if you have any additional questions. We'll see you then.